I just joined. So we've been doing something before we go to this basic instruction cycle. The main topic is instruction fetch and execute. It's very straightforward. Fetching the instruction and executing it. That is on your CPU, on your central processing unit. At the beginning of each instruction cycle, the processor fetches an instruction from memory. In a typical processor, a register called the program counter PC holds the address of the instruction to be fetched next. Unless told otherwise, the processor always increments the PC, that is the program counter, after each instruction fetch so that it will fetch the next instruction in sequence. That is the instruction located at the next higher memory address. The fetch and execute processes on your I think this topic came in after we studied registers or something like that. That's about the execution cycle. We first talked about register. If you recall when we were doing this, we talked about this diagram in full. Please refer to the video. I don't need to go back to that. We'll not be repeating ourselves every time. So our concern today is the fetch and execute cycle. And what they are trying to say here, but let's check this diagram. The diagram is telling us the processes that are involved in the fetching and execution of processes. And then we have the start is the beginning. Then it goes on to fetch the next instruction. That is the explanation we just know that is written here. From starting to fetching the next instruction and then execute instruction, and of course halt, that's like the end. Not really the end because it's just like a small pause. The execution continues. That is what is written here. If you check the other part of this, the way this works is that they said at the beginning of each instruction cycle, when the processor fetches an instruction. Hold on, I'm trying to look for an analogy to use for this because the best way we can remember some of these things is when we use something we are used to explain it. But while I'm trying to source that, I want someone to give their own ideas and opinion on this. Maybe you know better. You asking something. If you have anybody that wants to say something before I come up with an analogy for it. Are you guys still in class?
No, sir, we are in class. Uh,
Are
I
we,
said
we are,
it
we
is
are all
just
on the
like
same page. Okay.
I said it's just like sending a command. Once a command is sent into the computer, the CPU fetches that command just like an instruction being passed. So the CPU fetches the command, which is the instruction. So after fetching the instruction, it will now execute, process that data, which comes as an instruction, which is in the process of execution. Then after execution, the instruction now gives a feedback, which stands as the output. After which the whole process halts.
All right. Thank you. If you can recall in our last class, we were talking about the memories that we have that get themselves involved in some of these processes, when processes are ongoing on the in the CPU, like you mentioned. We'll talk about the RAM then, and then some other things like registers and the rest of them and their function. Please
like
let's
the
go back.
ma, the ma,
Thank you. So let's go back
memory
to that
acknowledgement
video.
system.
If you can't recall, go and watch it for better understanding. Now let's talk about this instruction fetch cycle in a very simple way so that we understand. We are no longer in the era of cramming to pass exam, e-exam. Now we are now in the era of testing our understanding. It's our understanding they want to know now. It's not like you now putting a word for word in the exam now. It's now what you understand. Write professionally. They ask you what is a pen. You define or describe a pen in your own understanding, but not far from what you've learned from the material. So let's consider this process like cooking. I like food, so let me use food. I've come up with this one now. I think everybody will be familiar with it. Let's say the CPU is like a chef cooking in the kitchen. You understand? Let's just say it like that, that the CPU is like a chef. What we're trying to do now is talk about instruction fetch and execute. And this diagram is giving us a picture of what is happening. But it's not, I think even with this diagram, we still have so many questions because it's still not clear. But we want to clarify that
Mm.
using something we understand. So assuming the CPU is like a chef cooking in the kitchen. And then let's assume the chef is using a recipe book. Like say there is a book containing the recipe you are going to follow, the steps you are going to follow to prepare the food that you want to prepare. Now that recipe book in this our own instruction fetch and execute processes that we are trying to, what am I doing here? That we are trying to study. The let's say that the recipe book represents the program that is stored in the main memory, which is the RAM, for instance. Don't forget that we are talking about processes. And if you remember the definition we gave of processes in the last class, those are ongoing activities, currently ongoing, not something you have done, something that is still on. And if you remember that RAM is responsible for that. So let's say the recipe book that the chef, which is the CPU, is following to perform the cooking activity is stored in the main memory, the RAM. Then each step in that book that is written in that book is one instruction. Let's just go. I will go slowly so that we understand what we're trying to do in this instruction fetch and execute. So we started by saying the CPU is a chef that want to cook in the kitchen. But that chef want to follow a recipe book. And we all know what is contained in the recipe book. Instruction step by step that has to be followed to get the desired result, the particular food you are trying to cook. So that recipe book is now like a program that is stored in the main memory. Bringing it now into computer is like a program that is stored in the main memory. Let's say, for instance, RAM, responsible for processes. Then each recipe step that is listed, like they say, step 1, wash the pot. Step 2, get curry. Step 3, get. So each step is one instruction in that program. The program is stored in the main memory in RAM, for instance, and then that program is containing instructions, steps. Now, what the chef is to do is to fetch and execute cycle. It means from the program, you fetch an instruction, then you execute it by practicing it, maybe on the maybe you are using gas cooker or whatever, and your pot and whatever you are using. So if the instruction number 1 says sanitize your kitchen, and you go to your kitchen to do sanitation, you sanitize your kitchen. What you have done is you have fetched the instruction from the program, which is from the recipe book in our example, and executed it by practicing what that instruction says in your kitchen. Or maybe step 2 says, get your pot ready, wash your pot thoroughly. You've gotten the instruction, that is fetch. You fetch from the recipe book and practice in your kitchen. Two things are happening there. I'm getting instruction, I'm obeying it, or I'm fulfilling it. So that is what the CPU does when it's trying to do fetch, instruction, and execute. The instructions are stored in the RAM as programs. The program is made up of set of instructions, just like a recipe book is made up of steps that you have to follow to get that food that you want to prepare. And then the work of the CPU now is to fetch and to execute. Now, how does that happen? In the case of you as a chef in the kitchen, getting instruction from the recipe book and practicing it in your kitchen to get the desired result. But in the case of the CPU, just like you too, when you open the recipe book, you read the first line. Let's say you have 20 steps written. The first thing you will do is not to go to step 20. You get that step 1, you read it. You understand? So when you read the first step, you understand? Before doing it, the reading of the recipe book comes before the doing. So you read step 1, then you go to the kitchen, even though you're already in the kitchen, then you start practicing. The same way computer will first consult the RAM where the program is stored as instructions. When it consults it, that consulting the RAM for the instruction is fetching. You understand? It's fetching. Then executing it, doing what the instruction says is execution. It's just like you open the book now, assuming I open the recipe book and I saw step 1 is add 5 grams of salt to the soup. That is instruction 1. Then I'm going to the soup. I get my scale, weigh the salt, 5 grams, pour it in the soup. What I've done is I've fetched instruction and I've executed it. The same thing the CPU do. The CPU will go to the memory. Don't forget the memory responsible for that is the RAM. It goes to the RAM, get the instruction that is there. You understand? Then execute it. So the meaning of fetch in that regard is that fetch means to read the next instruction from memory. What should I do next? You understand? You know that when you perform step 1 in your recipe book, what is on your mind is going to the recipe to get the next step. That is the same thing computer is doing. Step 1 has been done. You now go back to the RAM, get the next step to be done, the next instruction in this case. So when you fetch it, what happens in the CPU? You know that, let me use sorry that I'm using a very layman method of teaching today. But I just hope that it will help our understanding. When you as the chef, for instance, when you read add 5 grams of salt to the soup, do you know that you need to first understand that instruction so that you don't just go and fetch 5 kilograms and pour it in the soup? Understanding comes first. You have to know you have to understand the exact quantity of salt, the soup pot that you are pouring it into, the action you have to take. So just like you need to understand, the CPU also decodes the instruction. It doesn't only fetch it. You understand? Between the start, which is the beginning, and fetch next instruction, this arrow that is here, there is a process going on here. Why it fetches the next instruction. Now, this arrow, what happens here is understanding. This instruction fetched need to be processed, need to be understood before it will be executed. So the CPU will not just fetch and go to execute. It has to understand what the instruction is asking it to do. So is the instruction asking it to do an operation like arithmetic operation like addition or subtraction or multiplication, or is it asking me to compare something or to analyze something? So the computer will need to first digest that instruction before executing it. So the CPU does something now. It fetches the next instruction to be done from the RAM. The instruction is stored in the RAM in form of programs. So it fetches it from the RAM, understands it, then execute it. So that executing means carrying out the instruction. So that continue as a process. So that is what your CPU does every time you open this app, you are doing this, you are doing that. What is just, for instance, now as we are on Zoom, we open this PDF. There are so many things we are doing on this PDF. And why it is possible is that the CPU is fetching the next instruction from the RAM. That okay, the person has now clicked on minimize. It fetches the next instruction, understands it, then executes it. But it doesn't just stop there. The reason why it is hot that is here is that they halt it because if that cycle of instruction has been completed, another one is still coming, is still there. The next instruction will still come in. So it's a continuous process. As long as your CPU is on, your computer is on and is working, the process is continuous. It starts, it fetches, understand, execute, halt, start the next one again, because the more you work on the system, the more instructions it has to obey. What they're just trying to tell you is all these things we are doing on the computer, they are instructing the computer to do something. But the process behind it is what they are revealing to you. Don't forget, what we're doing here is computer architecture. You understand? What we're doing is computer architecture. And of course, we want to know what is happening when we do some things on the system, not just what happens. Why are they happening? So that is it. So for example, consider a computer in which each instruction occupies 116-bit word of memory. Assume that the program counter is set to location 300. The processor will next fetch the instruction at location 300. On succeeding instruction cycles, it will fetch instruction from locations 301, 302, 303, and so on. That is to tell you that it's a continuous uh, cycle.
Process.
Yes, the processes continue. It completes one cycle now and start another one. It doesn't just stop there. It completes one cycle,
Yeah.
it starts another one. It doesn't just stop there. So I think we are getting it more small. Uh-huh. So, and one thing is very important. Please, when we are seeing all these abbreviations, let's put them in mind. Let's put them in mind. They are very important. I think POP like testing abbreviations a lot. All right, so now the fetch instruction, we are now talking about when the computer, your CPU rather, when it fetches instruction from the RAM, which is where the program is stored. Instruction is stored as programs. When it is fetched, it is loaded into what we call register. Now they are even revealing more. They are not telling us more. They did not even stop at we just knowing that instruction is fetched, it is understood, and it is executed. They are not telling us where it is done exactly. So when the CPU fetches an instruction from the RAM, it is loaded into a register in the processor known as the instruction register, IR. The fetched instruction is loaded into a register known as the processor, a register in the processor, which is known as the instruction register. Now, the instruction contains bits that specify the action the processor is to take. So that instruction that is fetched and loaded into a register, what it contains is just bits of information, which which will tell the processor the type of action to take. I've mentioned it earlier that it will not show whether it is addition, subtraction, multiplication, analysis, or whatever that is needed to be done in that instruction. Now, the processor interprets the instruction and performs the required action. In general, these actions fall into four categories. The processor memory. Data may be transferred from processor to memory or from memory to processor. I mentioned that storage too, using RAM especially, for example. So we have four main actions that occurs in the process of the processor fetching, interpreting, and executing. The first one is the processor memory relationship. That is when data is transferred either from the processor to the memory or from the memory to the processor. And then the second one is the processor input output. When you see I/O in computer stuff, it's always the input or output, whether devices or operations. So it's not, we have processor to memory, then processor to input and output. And that time will be transferred to or from a peripheral device. That is a device that is not part of your computer, but is added to it. Like if you attach a flash to your system now, it's a peripheral. Like a printer now, if you attach it to your system, that is a peripheral device. It's not part of this computer. It's just an external device added to your computer. Now, a peripheral device be transferring between the processor and an input or output module. Now, the next one, which is the third one, we've talked about the processor to the memory now, and then the processor to the input and output device. Now, the data processing. Don't forget, we're talking about the four actions that takes place during the processing and the executing of the instruction, fetching, processing, and execution. Now, the next one is data processing. The processor may perform some arithmetic or logic operation on the data. That is after interpreting what is to be done. And then finally, control. An instruction may specify that the sequence of execution be altered. For example, the processor may fetch an instruction from location 149, which specifies that the next instruction is from location 182. Now, the processor will remember this fact by setting the program counter to 182. Thus, on the next fetch cycle, the instruction will be fetched from location 182 rather than 150. I hope you understand the aspect of control now, which means if there was no
Yes.
control,
Yes, sir.
if there was no control, the computer will just continue fetching instructions serially. After 150, 149, it will go to 150. But if my instruction is set to location 149, now, like the instruction I'm working on right now, on this particular thing I'm working on the system, is on 149. And what I want to do next is not on 150, it's on 182. I will need the control. The control will need to come in. When the control comes in, is one that will help the processor to understand where the next location is, rather than it deciding on its own to go serially. Like automatically, it will just think that the next location is 150. But when there is control, control will,
We
the
set the
work of
program
control
counter.
is to send it to the next program counter that you want to work on. So thus, on the next fetch cycle, the instruction will be fetched from location 182. So now, an instruction's execution may involve a combination of these actions. We've listed four actions. Don't forget the processor to the memory, the processor to the input and input device, the data processing, and the control. All this takes place in the process of fetching, understanding, that is interpretation, and also execution of your processes. But when processes are ongoing, some processes may combine more than one of those